Hello everybody, welcome into another lesson. So today we are going to talk about inverse functions. Of course, a function has an inverse if and only if it is one-to-one. And for the purposes of today, every function is one-to-one, so that means it's going to have an inverse. Here we have f of x equals negative 2x plus 5, a classic linear function. So it's definitely one-to-one since it's a linear function. So how would you proceed to find the inverse function? Well, convert that f of x into y. If you convert f of x into y, you can do that. You would get y equals negative 2x plus 5. Now, what you have to do, if we remember for inverse functions, the domain and the range switch places. That means the domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. What that means is you're going to switch places with x and y. So now you're going to have x equals negative 2y plus 5. So you have x equals negative 2y plus 5. We switch places with the x and y, then you just solve for y. Well, this would just end up giving you 2y equals negative x plus 5, which would end up giving you that y is equal to negative 1/2 x plus 5/2. Now, the final step is we got to convert that y back into function notation. But for an inverse function, here's how you would write it. The inverse function is always written as, it's going to look like f to the negative first of x. F to the negative first of x would then equal negative 1/2 x plus 5/2. So there is your inverse function. F inverse of x equals negative 1/2 x plus 5/2. Now, there is a way we can check this too to make sure we got the right inverse. How, you might ask? Here's how you're going to check it. Take f composition of f inverse. If it equals x, the composition always has to equal plain old x. If it equals anything else, then you did it wrong and you didn't get the inverse. So f composition of f inverse would then be, of course, f of f inverse x, which now you put this entire value in for the original function for the f of x, where the x is, so that's going to equal negative 2 times negative 1/2 x plus 5/2 plus 5. So let's go ahead and do this here. Negative 2 times negative 1/2 x gives you positive x. Then negative 2 times 5/2 would give you minus 5, then plus 5. So yes, you end up getting x. So that checks out. That the inverse is truly negative 1/2 x plus 5/2. Since you got f composition f inverse equal to x, it's the inverse then. If it equaled anything else, and I mean anything else but just x, it would not be the inverse. You can also do it backwards too. You can take f inverse composition of f, and you should also get x. So if you take f inverse composition of f, that's going to then be, of course, f inverse of f of x, which now you just put the entire value of f of x into the x value of the inverse. So that's going to equal negative 1/2 times that negative 2x plus 5, then plus 5/2. So negative 1/2 times negative 2x, that's positive x. Negative 1/2 times 5, that's minus 5/2. Then you just have a plus 5/2, which would simplify into x. So that checks out both ways then, that if you take f inverse composition of f, you also get x, meaning you found the inverse of the function. That is exactly how you're going to check. So you can take it either way to check your work. You could take f composition f inverse or f inverse composition of f. It really doesn't matter. And if you get anything but x as the result, it's not the inverse of the function. If you get x, you found the inverse. Let's do one more linear example, then we'll move on to some others. All right. F of x equals 3x minus 3. So we have f of x equals 3x minus 3. There's your original function. It's a linear, so that means it's 1 to 1. We can take the inverse. So now change that f of x into a y. You'll get y equals 3x minus 3. Now you switch places with the x and y. So you'd end up getting that x equals 3y minus 3. And then just solve for y. So then you get 3y is equal to x plus 3, which should end up giving you that y is equal to 1/3 x plus 1. And then for the final notation, that y will be converted to f inverse of x. So f inverse of x is equal to 1/3 x plus 1. That would be your inverse function. F inverse of x equals 1/3 x plus 1. Now let's just verify one of these ways. Let's take f composition of f inverse. See what we get. So that's going to be f of f inverse of x, which would give you 3 times that 1/3 x plus 1, that whole quantity, minus 3. 3 times 1/3 x is x, plus 3 times 1, that's plus 3. Then you have the minus 3. Well, what do you know? You get x. So we found the inverse. So f inverse of x equals 1/3 x plus 1. So linears are pretty easy. All right. Now, what if I give you something like f of x equals x to the 7th? So f of x equals x to the 7th power. Well, this is an odd power, so it's definitely 1 to 1. It's an odd power, so this is a 1 to 1 function. So once again, you'll convert that f of x into a y. So y would equal x to the 7th. Now switch places with your x and y, so x would equal y to the 7th. Then just solve for y. You would get y equals the 7th root of x. So y would equal the 7th root of x. So that means f inverse of x would equal the 7th root of x. So there's your inverse function. F inverse of x equals the 7th root of x. And if you take the compositions, you should get x. In fact, let's do that real quick here. So let's take f composition of the f inverse. So that's going to equal f of f inverse of x, which would then put in that 7th root of x, raise that to the 7th power, Well, that'll cancel out the root then. You'll just get x. So yes, we found the inverse with f inverse of x being the 7th root of x. All right. Now here's something different. F of x equals negative x to the 6th, where x is greater than or equal to 0. So f of x equals negative x to the 6th, where the domain is x is greater than or equal to 0. So notice something. We have an even power, which by itself would mean there's no inverse of the entire function. But if you restrict the domain, in this case x greater than or equal to 0, you can take the inverse of half of this. So let's change that change that f of x into a y. You'll get y equals negative x to the 6th. All right, now switch places with your x and y. You would get x equals negative y to the 6th, which would then, if you solve for y, well, first y to the 6th would end up equaling negative x, which means y is going to equal the 6th root of negative x. But is it going to be positive or negative? Well, x is greater than or equal to 0, so it's actually then, you're going to take the positive root. So, since x is greater than or equal to 0, you'll take the positive 6th root of that. So that means f inverse of x, in this case, would equal the 6th root of negative x. All right, now let's do the test here. Let's take f composition of f inverse. So that's going to be f of f inverse of x. So we'll put in that negative, that 6th root of negative x. We'll raise that to the, that's actually going to be negative on that 6th root of negative 6, a 6th root of negative x raised to the 6th power. Well, if you deal with the parentheses in the power, you'll end up literally getting negative of negative x, which would just give you x. So yes, you found the inverse for the domain where x is greater than or equal to 0 of the original function. That means your range becomes greater than or equal to 0 in the inverse. So yes, f inverse of x equals the 6th root of negative x when you restrict the domain. All right, let's do a few more here. F of x equals x to the 3rd plus 2. So we have f of x equals x to the 3rd plus 2. Well, of course, then this is an odd power function, so it's going to be 1 to 1. So change that f of x into a y. So y would equal x to the 3rd plus 2. Now you're just going to switch places with x and y. You would get x equals y to the 3rd plus 2, which would mean then that y to the 3rd is equal to x minus 2. So then y would be equal to the cube root of x minus 2. All right, so if y equals the cube root of x minus 2, that means that f inverse of x would equal the cube root of x minus 2. And I think by now we have a good grasp on how to verify that we found the inverse. So f inverse of x would equal the cube root of x minus 2. F of x equals negative 2x to the fifth plus 1/3. Alright, so we have f of x equals negative 2x to the fifth plus 1/3. So that means let's convert that f of x into a y. So y would equal negative 2x to the fifth plus 1/3. Alright, so now we've done that, let's switch places with the x and y. So x would equal negative 2y to the fifth plus 1/3. So this means then that 2y to the fifth would equal negative x plus 1/3. So then y to the fifth would equal negative 1/2 x plus 1/6. So then y would have to equal the fifth root of negative 1/2 x plus 1/6. Which then, last but not least, is going to mean then that f inverse of x will then equal that fifth root of negative 1/2 x plus 1/6. So what an inverse, huh? But yeah, f inverse of x would equal the fifth root of negative 1/2 x plus 1/6. That's exactly what you'd end up getting. I think I got about 4 more here. F of x equals 2 minus 2x squared, where x is less than or equal to 0. So very interesting. We have a quadratic function which by itself would not be 1-to-1. However, we've restricted the domain to where x is less than or equal to 0. So we'll get half of the parabola, which means it would be 1-to-1 for this part of the domain, which means for the inverse, your range will become less than or equal to 0. So that means we can do an inverse for this. So y would then equal 2 minus 2x squared. Now switch places with x and y, so x would end up equaling 2 minus 2y squared. Alright, well, let's see, this means that 2y squared would equal 2 minus x, which then means that y squared would end up equaling 1 minus 1/2 x. Okay, so now we got to solve for the square root of both sides. So y would equal, now the domain of the original is x is less than or equal to 0. That means you're going to take actually the negative square root of the right hand side. So y would equal the negative square root of 1 minus 1/2 x. So that means that f inverse of x would end up equaling negative of the square root of 1 minus 1/2 x. That would be the inverse function for that branch. So, yeah, f inverse of x equals negative of the square root of 1 minus 1/2 x. I have about 3 more. F of x equals 3/5 x to the third minus 9. All right. So f of x equals 3/5 x to the third minus 9. All right, so let's convert this then into y equals 3/5 x to the third minus 9. Now switch places with your x and y, so x would equal 3/5 y to the third minus 9. All right, so then 3/5 y to the third equals x plus 9. So then y to the third would end up equaling 5/3 x plus, let's see, plus 15. So y to the third would equal 5/3 x plus 15, which then means that y would equal the cube root of 5/3 x plus 15. So, in other words, then your inverse function, f inverse of x, would equal the cube root of 5/3 x plus 15. So there's your inverse function. F inverse of x would equal the cube root of 5/3 x plus 15. I have about 2 more. Do a double take there. Okay. F of x equals x to the fourth minus 1/2 for where x is greater than or equal to 0. So we have another even power function, which means in and of itself would not be 1-to-1. However, the domain is restricted to where x is greater than or equal to 0. So for that piece of it, we do have an inverse. So let's make y equal to x to the fourth minus 1/2. Now just switch places with your x and y. X would equal y to the fourth minus 1/2, which means y to the fourth is going to equal x plus 1/2. Now we got to take the fourth root of both sides to solve for y. Since the domain being x is greater than or equal to 0, that means the range of the new function will be greater than or equal to 0, which also means that we're going to take the positive fourth root of the right side. So that means y is going to equal the fourth root of x plus 1/2. So, in other words, f inverse of x would end up equaling the fourth root of x plus 1/2. So that would be your inverse function. F inverse of x equals the fourth root of x plus 1/2. So I have one more. All right, f of x equals 1/6 times x to the 5th plus 2/3. All right, so f of x equals 1/6 x to the 5th plus 2/3. It's an odd power function, so it's definitely 1 to 1. All right, so then that means y equals 1/6 times x to the 5th plus 2/3. Now switch places with your x and y, so that means x would equal 1/6 y to the 5th plus 2/3. So then 1/6 y to the 5th would equal x minus 2/3. So then y to the 5th would end up equaling 6x minus 4. Which then means that y would equal the 5th root of 6x minus 4. In other words, then, your inverse function, f inverse of x, would be equal to the 5th root of 6x minus 4. So there you go. There you have your inverse function. So that's it for this lesson. Next lesson, we're going to graph the square root and cube root functions, which is also going to go to illustrate how inverse functions look graphically and how they relate to their inverse functions of the square root and cube root functions. So I hope everyone has a great night. Take care.